new equation of f of x if you triple the amplitude, guys. If you triple the amplitude and decrease the midline by 4. So a way of thinking through this is you can kind of draw just like a rough picture. What do I originally start with? This. So rough picture, I have an amplitude of 3, right? Oh, that got moved on the. I gotta recalibrate just a second. Okay, so we have an amplitude of 3 and negative 3, right? If your amplitude if it bounces between 3 and negative 3, everybody, right? Then we have the sine function. Oh, it should have touched up there. Da, 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 da. Okay, that part doesn't matter. Was there any shift left and right or up and down? No. Okay. So it says, write a new equation of f of x if you triple the amplitude. So that part's easy. What's 3 triple? 3 plus 3 plus 3. That's triples, right? Or 3 times 3, right? Which is 9. So my new amplitude will be 9. So I know it's going to be f of x is equal to 9. And then it's going to be sine of some, let's see. Okay, so there was no shift, right? There was no shift left and right, no shift. Oh, but was there a shift up and down? It says, and then decrease the midline by 4. So wouldn't that be taking our equation? What's our midline at right now? What's our midline at right now? 0, right? So if we shift it down 4, wouldn't that be shifting it down 4? Yeah, so down 1, 2, 3, negative 4. So our new midline's right here, right? Does that change our amplitude is tripled, but does everybody see that it just shifts the function down 4? Well, sure means no. So yes or no? Does it make sense? If you decrease the midline and it was at 0, you shifted it down 4 units, the whole function. Okay, now does that get added in with x or on the outside? Outside. Anything added with x is your shift left and right. So it didn't say anything about the period or anything, so it's going to stay the same. So we have pi half x, and then we shifted it down 4, so minus 4. If you added it in with x, then you shifted it left and right. Decrease the midline by 4, so it'd be down 4. You don't, what? Well, I only saw her one person, so good job. How many got 100% right? Okay, awesome. So last time we learned about the law of sine. So remember, if you have a right triangle, this is not the law of sine. If you have a right triangle, this is what you focus in secondary math 1 and 2. Once again, when you have a right triangle, you can find missing sides and missing angles using right triangle trig or the Pythagorean theorem. This is a good review for many of you because I bet some of you didn't even learn this and you will see this on your ACT, guaranteed. Does everybody see how this is a right triangle? Yeah. So we can use right triangle trigonometry to find missing sides or angles. So everybody look, we're trying to find angle x. This is not what we learned the other day. I'm just reviewing this with you. Because it's a right triangle, we can use right triangle trig. From x, isn't this the opposite side? Isn't this the hypotenuse? So that is opposite over hypotenuse, which is sine, right, everybody? Do you remember that? Oh, heck, another hour of agony. Sine, cosine, tangent. Please tell me you learned this. Well, you have. You have learned it, yes. Oh, yeah, that's fine too. Same thing. Yeah. So sine is opposite over hypotenuse. So we have sine of x is equal to 3 over 5, right, everybody? And now to solve for x, don't we need to undo sine? So we take the sine inverse, right? So we have sine inverse of both sides. So we have x is equal to the sine inverse of 3 divided by 5. Go, type it in. Make sure it's in degrees. Aren't we finding an angle in degrees? Go, type it in. Sine inverse of 3 divided by 5. What's that? 36.8 degrees? 36.9 degrees, okay? So we could use right triangle trig to solve this one. Why don't you guys all have a calculator? You can rent one for $10 from the office. Okay, looking at this one. Looking at this one, we have a right triangle, right? So we can solve missing side lengths using right triangle trig. Can we use the Pythagorean theorem? No. Do we have enough information to use the Pythagorean theorem? So we have to use right triangle trig. The only angle we have is 30. Well, we have 33 degrees. Let's use it. So we're going to use opposite, and this is adjacent, right, everybody? So that's tangent. Do you remember that? Tangent is opposite over adjacent. Oh dear. Okay. This is how I teach it. Sine, cosine, tangent. Everybody, do you see that?
Yes.
Okay. Sine, cosine, tangent. The saying is, oh heck, another hour of agony. So, off agony. Opposite over adjacent would be Tangent. So we're going to use tangent. So we have tangent of theta, but theta is 33. So we have tangent of 33 is equal to opposite over adjacent. So we have x over 4. Solve for x algebraically. What will we do to get x alone? Multiply both sides by 4. Divide that over here. So we have x is equal to 4 tangent of 33. Type it in. What do you get for x? 2.6. Awesome. Did everybody get 2.6? Okay. Okay, so this is right triangle trig. You learned this last year. Okay, right triangle. We're looking at this one. If I said find x, we won't use right triangle trig, but we will use the Pythagorean theorem. If you have two sides of a triangle and it's a right triangle, you can find the missing side. But make sure you set it up correct, guys. Pythagorean theorem is side 1 squared plus side 2 squared is equal to the hypotenuse squared. So side 1 squared would be 5 squared, right? 5 squared plus, here's the common mistake. People think you can do 5 squared plus 12 squared is equal to x squared. No, it has to equal the hypotenuse squared. So 5 squared plus x squared is equal to hypotenuse squared, 12 squared. Does everybody see what I'm saying? This is just a reminder because you guys have learned this last year. So solving for x, you would subtract 5 squared, take the square root. So you have 12 squared minus 5 squared. Take the square root. Am I going too fast? Yeah. Okay, so x is equal to what? Go. 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 Type it. Go. 12 squared minus 5 squared is equal to 119. You take the square root of that. 10.9. Okay. Okay. So you can find missing sides and angles with right triangle trig. However, we now are in secondary 3, and you're not always going to be given a right triangle. In fact, unless you have that little square, you can never assume, even if it looks 90 degrees, you can never assume you have a right triangle. Unless it says in the instructions you have a right triangle, or in the picture you know you have a right triangle. So we still have to be able to find missing lengths of angle or missing lengths of sides and missing angles. And so now we've learned the law of sines. In secondary math 3, now you can find any triangles, missing angles, and sides using the law of sines. So remember, so do you understand what I'm saying? If you don't have a right triangle, you can still find missing angles and sides, but you'll use the law of sines. So we have triangle ABC. We know that angles are written in big letters, so angle A, angle B, angle C. The side across from that angle is the corresponding side. So if this is angle A, this is side A. Sides are written in small letters. If this is angle C, this is side C. And then if this is angle B, this is side B. And we learned that the law of sines says sine of angle A divided by A will be equal to sine of angle B divided by B, which will be equal to sine of angle C over C. Do you all remember learning this the other day? Okay, let's just apply it. Oh yeah, one more reminder. You can use the law of sines when you have two angles on any side. So if you have two angles on any side, you can use the law of sines, because you can always find that third angle, so you can use the law of sines. You can use the law of sines if you have an acute angle, which means less than 90 degrees, and two sides, as long as the side across from the acute angle is larger than the other side. So notice we have 40 degrees, that's an acute angle, it's less than 90 degrees. The side across from it is 10, which is larger than the other side. Therefore, we can use the law of sines. And then on this one, we can use the law of sines if you have an obtuse angle. So make sure you're paying attention to this, because I made sure to put some problems on the test where I'm asking you in words when you can use the law of sines and when you can use the law of cosines. So a lot of you don't pay attention to like little details, and then you're going to not do as well. And you can use the law of sines if you have an obtuse angle, which means greater than 90 degrees, as long as one of the other two sides given is across from that angle. So we have 110 degrees, and that's across from 12, so we're good, one of the sides. It doesn't matter if it's larger or smaller, as long as it's across from one of the given sides. So look, if the 12 was over here, if the 12 was right here, we could not use the law of sines to solve, because it's not across from one of the given sides. Okay. Okay, so with that being said, remember that. Okay, let's go ahead and just practice a few off the worksheet. Here we go. So number 10. You've probably already done it, so just check your answer. So it says, in triangle MNP, Angle P is 33 degrees. The measure, side N is 54 feet. Side P is 63 feet. Find the measure of angle N. So I draw a picture, and then I'll look and say, because I'm not going to say to you on the test, use the law of sines. You have to know if you can or can't. I'm going to give you a question, and you have to decide how can I solve it. So I'm going to draw a picture here. So I draw in a round triangle. It doesn't need to be drawn to scale, as long as I understand what's going on. So I have M and P. Now I've got to fill in the information correctly. So we know that the measure of angle P is 33 degrees. So I'm going to write that in, 33 degrees. And then side N is 54 feet. So across from side N is 54 feet. And then aside from cross P is 63 feet. Now it says, find the measure of angle N. So we're trying to find, I'm just going to put an X right there. Why not? So let's see, can we use the law of sines? So we have an angle and a side across from it, right? Is it an acute angle? Yes. Is the side across from it larger than the other given side? Yeah, so we can go ahead and use the law of sines. So we're going to be definitely using that angle because we have the side across from it. And then we are finding that angle. The good news is we have the side across from it. So we'll set up our ratio. We have sine of the angle, so sine of 33, divided by the side across from it, 63, will be equal to sine of angle N, so sine of X, divided by the side across from that, which is 54. Now it's just algebra to solve for X. So we cross multiply by, because we're solving for X, I'm going to multiply 54 over to this side. Well, technically, mathematically, I'm multiplying it to both sides, but watch very carefully because a lot of you are messing this up. 54 over 54 divides out to be 1. Does everybody see? Now to get X alone, I've got to undo sine. The only way to get sine to go away is to take the inverse sine, right? So we technically take the inverse sine of both sides. So sine inverse, I like to write it in front because that's what it's going to be. So I have, on the left, I should give myself some room. So I really have sine inverse of all that stuff, So we have sine inverse of 54 sine of 33 divided by 63, and that's equal to, our inverse sine and sine cancel out, is equal to X. So we're almost done. Type it into your calculator. Go. 27 point, let's see, number 10. Good. 27.8 degrees. So X is equal to 27.8 degrees. So that was the measure of angle N. So angle N is 27.8 degrees. Questions on that? And once again, your picture should make sense. 27.8 is smaller than 33. The side across was smaller than the side across from that. So if your picture doesn't make sense, you've done something wrong. Okay, next one. Questions on that? Okay, pay very close attention because some people can't do these for some reason. So it's not any different. It says, number 12, I'm doing it with you. You're going to need some room to write. It says, find the remaining sides and angles. So we've got to find all sides, all angles of this triangle. So I'm drawing in a triangle. I have triangle PQR, so PQR. Then I'm filling it in. In this one it says, the measure of angle Q is 64 degrees. The measure of angle R is 64 degrees. And side R is 8. Now we're finding all the missing sides and all the missing angles. So first of all, isn't it really easy to find the third angle in this one? 180 minus 64 minus 64, you get 52. So angle P, I'm going to change colors here. So my new answers, and I want you to be specific so I can check your work easy. Either draw a really beautiful picture so I can just look at my picture or label it. So angle P is 52 degrees. 52 degrees. So we know this is 52 degrees. Questions on how I got that? So then from there, we need to find side P, right? Here's angle P, so that's side P and side Q. So now I'm going to set up a sine ratio for both of those. So I'm going to definitely use this side, so I need that angle. So sine of 64 over 8. Is everybody good? Will be equal to, let's find this side, so sine of 64 over Q, right? sine of 64 over q. Let's quickly find q. So we would cross multiply by q. Which it divides out over here. I'd multiply by 8. Divides out over here. Now to get q alone, I'll divide by, so I have q sine of 64 is equal to 8 sine of 64. Now solving for q algebraically, divide both sides by sine of 64. You can either type it into your calculator or recognize. So now q's alone. I recognize anything divided by itself is 1, so that leaves me with 8. So p is 8, which actually that makes perfect sense. Sorry, q is 8, which actually that makes perfect sense. Because if this angle 64, the side across from it's 8, and this angle 64, the side across better be the same. Does that make sense, everybody? Okay, so we did it algebraically, which is great. Now to find p, you cannot use the Pythagorean theorem. This is not a right triangle. That is one of the most common errors for people to do on like an ACT test. So we would set up a law of sine. So we would say sine of, I'm trying to find p, so sine of 52 over p is equal to sine of 64 over 8. So then we would cross multiply again, and we would get p is equal to 7. So p is equal to 7. Do I need to go through the algebra on that? I feel like we're probably at this point good with the algebra. Okay, awesome. So do you see how I went about this? Okay, one more, and then I'm just going to let you work. Okay, so in triangle ABC, the measure of angle A is 25 degrees, and the measure of angle B is 50 degrees. Find AC for BC is 6.2. So I'm just doing this one more with you, and then I'll let you work. So I'm doing number 19 with you, so I'm making it easier on you. So I'm going to draw a picture over here. So it says ABC, so I'm going to label it ABC. And then put in what I know. So it says the measure of angle B is 50 degrees. So I'm putting in a 50. And then in this one it says find AC. So I'm going to put an X right here. And BC is 6.2. So BC is 6.2. So now that's all we're given. Oh, and measure of angle A is 25 degrees. I missed that. Okay, everybody comfortable up to here? So now let's go ahead and solve for X. So we definitely have this angle and that side, so we'll definitely use that. So we'll say sine of 25 over 6.2 will be equal to, well, in this one, the nice thing is we're given the angle 50 and it's across from X. So we know it's equal to sine of 50 over X, then we cross multiply. So X sine of 25 is equal to 6.2 sine of 50. We're cross multiplying. I'm skipping some steps, but I think you guys said you were comfortable with your algebra. So divide by sine of 25. So now X is alone, so you get X is equal to 11.2. So AC is 11.2. Okay. Are you good with that one? So really, we're just practicing more with the law signs. This one was kind of hard. If you feel really comfortable with area from last time, I won't go through it. I'll just let you work. The rest of the time's yours. Do you want me to go through one with area, or do you feel good with it? Remember how to find area. 1/2 times one side 1 times the second side times by sine of the angle in between. Do you or do you not want me to go through this one? Okay, we'll go through it. Okay. So number 15. Then the rest of the time's yours after this. So probably good to stay with me then. So it says find the area of ABC round to the nearest tenth. So this one actually is going to take a little bit of work before we can find the area, because let's look at, I'm going to move this up a little. Let's look at what we're looking at here. Okay, oh man. Okay, so I'm going to draw a picture real quick. So I have triangle ABC. Let's make it bigger, because otherwise you might mess it up. So we have triangle ABC. We're given that angle B is 28 degrees. We're given that angle C is 70 degrees. And we're given that side A is 9.8. Okay, sorry, that's low. Okay, so now remember, to find the area, the formula for that is area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between those two sides. Angle between. Okay, so the angle in between. So let's see if we have enough information. 1/2 times side 1 times side 2. Do we have side 2? No, so either one could be considered side 2. I'm randomly going to say, okay, I'm going to call that side 2. Okay, so we're going to have to go through and, well, I'm going to actually, either one works, but isn't this the angle we have? So let's just call this side 2, x over here. It doesn't matter though, because we could really use either or. Okay, I'm going to call this x. Okay, so let's set up the law of sines. Let's set up the law of sines to find that side. So we're going to need this angle for sure, right? So 180 minus 28 minus 70. $18? 82. Okay, so we have 82 degrees. Okay, so let's find this side. So we have sine of 82 over 9.8 will be equal to sine of 70. So really either one would have worked over x. Now when we solve for x, we'll be good. So we'll cross multiply and solve for x. So we have x is equal to 9.8 sine of 70, if you go through the algebra, divided by sine of 82. So what'd you get? Anybody? What was it? 9.3, okay. So we get 9.3. So I'm going to write that in. So now we know this side is 9.3. And now look, don't we have a side 1, a side 2, and an angle in between? Yeah? So now we can continue to find the area. So we know that area is equal to 1/2 times side 1, which is 9.3, times side 2, which is 9.8, times by sine of 28, the angle in between. Now I actually did it the other way. I found this side. I promise you'll get the same area no matter how you go about it, as long as you've done everything correctly. So what do you get as your area for 15? 20. What'd you get? Are you sure? Did we round the 9. Did anybody else get 9.3? Oh, that's going to change it. So
I got 21.39.
You got 21. Yeah, because when I did it the other way, I got 22.1. So we should come out the same. So either this is off or else mine's off. Are you sure this is 9.3? You got 9.2? Let's see if that's closer. 0.5 times 9.2 times 9.8 times sine of 28. 21. Okay. So here's the deal. We're all going to come out a little bit differently unless we use the full decimal. So as long as you're within like 1 to 2 decimal places, I'll accept it. Because we rounded this, right? And it was like a huge long decimal. If we type in the full decimals, we should come out the same. Okay, so area is equal to 21.2-ish, right? Everybody, is that what we were getting here? Okay, so that one took a little bit of work. Okay, so finish the worksheet. The rest of the time's yours. So you have like 40 minutes. The rest of the time's yours. Finish the worksheet. Get them right, though. Yes.